Lab safety is extremely important, not only in high school lab classes, but also for any industrial, commercial, even home laboratories. Think about safety every time you do anything, because it doesn't take much to cause a serious accident or injury. First of all, this program will not list all hazards or potential hazards in a lab environment, and it's not intended to teach you everything you need to know about lab safety. It's designed to make you more aware of the need for safety, particularly in school science labs. You'll learn more from your teacher, who has the experience and knowledge to help you enjoy a safe and healthful lab class. Always follow your teacher's instructions. Don't take shortcuts, don't experiment on your own, and use only the materials authorized by your teacher. You're working with chemicals and hazardous materials. Therefore, strict compliance with school safety rules is mandatory. Let's begin with some basics. Never work alone in a science lab or chemical storage area. Never eat, drink, smoke, or chew gum or tobacco in labs or storage areas. Chew gum? Yes, chemicals can be absorbed into the gum, and when chewed, the chemicals can be ingested. Never use your mouth to blow or create a vacuum in a chemical tube or pipe. Always wash your hands before and after work in a lab, also immediately after any spill cleanup. Restrain loose clothing to avoid causing a spill or absorbing a chemical. Keep long hair tied back and restrict dangling jewelry. Never leave heat sources unattended, such as gas burners, hot plates, sand baths, or electric tools and motors. When working with reagents, always return them to proper storage. Don't leave them sitting on work benches. Reactive chemicals should be carefully controlled to avoid spilling or breaking. Don't set them near lab bench edges. Use fume hoods for volatile and hazardous chemicals, but of course never lean into the fume hood. Don't use the fume hood as a storage area. When personal protection is required, both the lab worker and lab partner must wear the protection. Don't mix chemicals in the sink drain. Always follow your teacher's instructions when disposing of chemicals. Pouring chemical waste down the drain can be extremely hazardous and violate environmental laws. And always follow emergency action procedures in the event of an emergency. Certainly there are more safety rules, such as having separate containers for trash and broken glass, checking eye wash stations frequently, and knowing how to use these eye wash stations, properly securing all gas cylinders when in use, and transporting these cylinders secured on a hand truck, paying particular attention when storing chemicals to make sure the shelves are stable and chemicals are put in their proper place. It all adds up to individual responsibility. You are the only person who can prevent accidents and injuries in school labs. Okay, let's quickly review some terminology relating to chemicals used in science labs. Carcinogens. Substances capable of causing cancer or cancerous growths in mammals. Some of these chemicals include asbestos, benzene, chromium powder, sodium nitrate, formaldehyde, chloroform, and others. Toxics. Agents or substances which, when inhaled, absorbed, or ingested in small amounts, can cause death, disablement, or severe illness. They include chlorine, mercury, nicotine, potassium cyanide, and others. Explosives. Unstable substances capable of rapid and violent energy release. This group includes carbon disulfide, butyric acid, ether, and many more. Corrosives. Substances that cause destruction of tissue by chemical action on contact. Corrosives include sulfuric acid, acetic acid, hydrochloric acid, nitric acid, and many others. Irritants. Substances that on immediate, prolonged, or repeated contact with normal tissue will induce a local inflammatory reaction. Irritants include ferric chloride, hydrogen peroxide, methyl ethyl ketone, potassium permanganate, and quite a few others. Of course, the old standbys, flammables and combustibles, are also classes of liquids requiring special attention and respect. Flammable liquids are those liquids with a flash point of 100 degrees Fahrenheit or lower. Acetone, gasoline, carbon disulfide, and others fall into this category. The flash point of a liquid is the lowest temperature at which the liquid gives off enough vapor in a test vessel to form an ignitable mixture with air to produce a flame when a source of ignition is brought close to the surface of the liquid. To have a fire occur, you need basically three things: the fuel, such as gasoline, oxygen, and a source of ignition. That source of ignition could be a match, a spark, or even static electricity. When the proper mixture of oxygen and fuel are present, that mixture can be ignited by a source of ignition. We want to emphasize flammables, as anytime you handle flammable liquids, you need to know the hazards and take precautions to reduce the risks. Storing flammable liquids in glass containers or non-safety containers such as this gas can is asking for a fire. Break the glass and the liquid spills. Add in a source of ignition and you have a fire or explosion. Using non-approved gas cans is equally dangerous. An approved safety container has a spring-loaded lid which prevents spills, but it also allows the container to breathe. As you know from your classroom studies, when the temperature of a substance is increased, its molecules are made to jiggle faster. The increased collisions between molecules force them to move farther apart, resulting in an expansion of the substance. If you fill your gas tank, then allow the car to sit in the sun, the tank may overflow due to the expansion of the liquid. The same thing happens in gasoline cans. As the temperature rises, pressure increases inside the can. If you don't release the pressure, the can may burst or spring a leak. Approved safety containers allow the pressure to escape, avoiding damage to the container. Another part of an approved safety container is the flame arrestor. It looks like a metal filter. This flame arrestor prevents a flame from entering the can, should the vapors or liquid catch on fire. The non-approved safety cans don't have flame arrestors, therefore they can be extremely hazardous. Combustible liquids such as kerosene, solvent, metal sodium, and others have higher flash points, but they can also catch on fire under favorable air-fuel mixtures and with sources of ignition. Fire is always a potential hazard in science labs, so follow your school's procedures and your teacher's instructions. Okay, now let's protective equipment that's issued to you to reduce both physical and health hazards. Eye protection comes in many forms: safety glasses, goggles, and face shields. These items are designed to protect your eyes from hazards. They won't do you any good if you don't wear them when required. A very small amount of hazardous chemical in your eye, such as sulfuric acid, chlorine, hydrochloric acid, and many others, can severely burn your eyes and cause permanent damage. Chemical gloves are necessary to prevent skin damage. Respirators prevent harmful vapors or fumes from entering your respiratory system. When required, be sure to wear these respirators according to your teacher's instructions. Naturally, there are chemical aprons and other protective equipment, but you'll learn from experience and your teacher when and what to wear for each experiment. This equipment won't do you any good if you don't use it. Glassware in labs can be particularly hazardous. Don't use broken, chipped, or badly scratched glassware. Be particularly cautious when trying to remove frozen or stuck stoppers. When inserting tubes into stoppers, Protect your hands by using gloves, towels, or tubing holders. Lubricate the tubing with water or glycerin. Keep your hand on the tubing close to the stopper and away from the end of the tube. Again, common sense and following your teacher's instructions will go a long way in preventing accidents. We didn't talk about chemical storage or labeling requirements, but you should always label all chemicals. It's too easy to get them mixed up, and there are many chemicals that react differently with other chemicals. The more work you complete in labs, the more you'll learn about safety and how to reduce both the physical and health hazards of the substances used in experiments. Begin now to develop a healthy respect for chemicals and hazardous materials. Keep in mind these same basic chemicals and hazardous materials can be used and stored in your home. Read the labels on some of the chemicals in your home. One rule you should always follow with chemicals is to never mix chemicals without proper training or knowledge of what you're doing. Sounds too simple, but each year there are many deaths in the home from people mixing common ammonia with a chlorine-based cleaner. You see, mixing ammonia with a chlorine cleaner creates a deadly gas called chloramine. Don't mix chemicals unless you have the training and knowledge. Always read and follow the chemical manufacturer's instructions. Another favorite is to disregard the prescribed amount of chemical to be used. If 1 teaspoon is supposed to work okay, then shouldn't 2 teaspoons be better? Not so. Chemical manufacturers have specific instructions on how much to use and when to use it for a purpose. At school, you can't afford to take chances. Lab experiments have specific requirements, so be sure you follow these requirements exactly. No reason to do it any other way. Okay, gang, that's about it for now. But let me assure you, safety is an important responsibility, and you're the only person who can make it happen. Take time for safety. Safety matters, and you matter. Safety will even help you get good grades in science labs. Thank you.